Cool. Hopefully everyone's digesting lunch well. It's the first session after lunch, so if you take a nap, that's also okay. My session is buzzing across the cloud-native landscape with eBPF. I'm Bill Mulligan. I'm a community pollinator, as I like to say. I like to help the Cilium and eBPF communities grow and blossom. So with that, first, how many people recognize this logo here? And when you see this logo, who thinks of the little thing that goes with it, dun 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 dun, right? And then how many people actually know what Intel Inside means? Okay, so big difference there, right? But the cool thing about this was everybody wanted either the laptop, the desktop, the server with Intel Inside because it was Intel Inside, right? Not because they knew exactly what it was, but because they thought what was inside would provide them a better experience, a better computing experience. Hence, they bought into the idea that Intel Inside would be better for whatever they were trying to accomplish. And so what I'm going to try to argue in this talk is that eBPF is actually the exact same thing. Not everybody is going to know what it is, but everybody is going to want products or services or other things with eBPF inside because of what it enables them to do. You're not going to have to be diving into the actual bytecode, but you are going to be taking advantage of what eBPF brings to you. And by the end of this, you'll be wanting applications with eBPF inside. I'm still working on the jingle. So the first thing that we have is in the traditional Linux kernel, we kind of have this kernel space, user space paradox, where the kernel has complete system awareness in terms of performance, visibility. Everything has to go to the kernel to actually access the hardware. But it doesn't really have the flexibility that needed. And most applications right now are written in user space because we have that flexibility. It's much more programmable, but it kind of gives up that access to different kernel structures and resources. And so when you're building an application right now on the infrastructure side, you either have to choose user space for flexibility or kernel space for the performance and visibility. And you have to choose one or the other. Now, the question is, how can you combine the benefits and advantages of both and move that flexibility from user space into kernel space? And adding that programmability to the kernel, and then how will that benefit us in cloud-native environments? So that's where eBPF comes in. So what is eBPF? So eBPF makes the Linux kernel programmable. And what exactly does that mean? So another example that people like to give is eBPF is to the Linux kernel what JavaScript is to the browser, right? If you think back to the original websites, you kind of had static web pages with information on them. As we move towards more, Web 2.0, not Web 3.0 yet, you kind of get interactive elements, so forms, clickable buttons, interactive parts, and that was provided by JavaScript. So eBPF did the same thing by extending the functionality instead of the web page, the Linux kernel. And this is a great quote from Linus. So eBPF has actually been really useful, and the real power of it is how it allows people to do specialized code that isn't enabled until it's asked for, right? So adding this programmability into something that's a decades-old technology at this point, and sometimes hard to move forwards and innovate at the same rate that we'd like. So eBPF allows us to dynamically change the kernel behavior. And this is, I think, a good illustration of what that is and how things usually work in Linux kernel development, right? So you have an application developer and I'm building out this great application, I need a new feature in it. And so, but it's missing right now in the Linux kernel. And so you go to your kernel developer, Daniel or Thomas or someone else, and you say, please add this to Linux kernel. And the Linux kernel developer is like, okay, I'm going to need a year to convince everybody in the community, go through all the different mailing lists before everybody is going to be like, okay, we can merge that patch in. So great. 1 year later, they're done. Upstream kernel now supports it. But that application developer doesn't have it in their distro. For it to actually trickle down into the LTS release of their vendors, that's going to take 3, maybe 5 years. Like I know people that are still running like 3.10 kernels in production, right? We're on 6 now, so it's, quite different. And 5 years from now, your requirements and what you're going to need from your infrastructure, from your kernel, is actually going to change, right? And so this isn't a very great feedback loop for us. Now with eBPF, since we're able to dynamically program the kernel, if you want to add a new feature to, let's say, observe your application, instead of having to convince the whole upstream community to do that, you can actually add a program with eBPF to be able to do that. And the great thing is eBPF allows you to do that even without rebooting your machine. So you can add functionality on the fly in a very dynamic way. So eBPF programs run on events, and this can be lots of different things. So things like kprobes or uprobes, system calls, trace points, basically anything that's calling into the Linux kernel, you can hook into with eBPF. So the kernel is seeing everything that's going on, and eBPF can hook into that and act on that happening. And as Brendan Greg coined, this is kind of like superpowers for the Linux kernel, right? Right now, all I've been saying is like, yeah, just sprinkle some magic pixie dust on top of all of it, and it's all solved. And that's kind of what eBPF is for the Linux kernel. And let's say it's not magic anymore. Like, let's actually dive into how eBPF actually works. And I think the key things here that you want to think about is the kernel is like a very critical system, right? So you want to have something that's safe and performant. Otherwise, if you're crashing your kernel, not very many people are going to be happy, and you're not going to be using eBPF for very much longer. So the first thing that eBPF has built in is this safety component. So that's where the eBPF verifier comes in. So you write your eBPF program, and before you can load it into the Linux kernel, it needs to pass through the eBPF verifier. And the verifier does a bunch of things, but kind of the most important things is it checks that the programs run to completion and that they're not going to crash or otherwise harm the system, right? You want to keep the kernel safe if you're going to put things into kernel space, and that's what the eBPF verifier does. The second part is around performance, right? When we're looking at the user space, kernel space paradox, you want to be able to put things in the kernel because it's a more performant way to do that. And so how eBPF helps you do that is it takes the bytecode of your program and translates it into the machine specific instruction set. And then it basically runs as efficiently as natively compiled kernel code. So rather than having, transferring something from kernel space to user space and then processing it there, you can process something directly in kernel space at native execution speed. So you get a massive performance boost from eBPF. And then if you do want to export something to user space and for further processing or collection or aggregation for future uses, you can also share that back into user space. And the way that you do this is through BPF maps. And what this allows you to do is to take whatever information or data you've collected in kernel space and send it out to user space. And the great thing about this is that since you're collecting all the data in the kernel, you're not going to lose any data. And once again, since it's running in the kernel, it's going to be much more performant for you. So let's then talk about how eBPF connects to cloud native, because that was originally the premise of this talk, right? And so in a cloud native world, rather than running one application on a machine or on a virtual machine, we now have a collection of containers running on a single kernel, right? And so there's one kernel per host, and it's supporting all the containers and applications that are running on that host. So what does this mean for eBPF? So since the kernel is aware of everything that's happening on the host, like creating containers, accessing files, creating different network connections, it's seeing everything that's happening, right? As we said before, everything that you want to do in as an application basically has to go through the kernel. The kernel's seeing everything that's happening in user space. And that means that also eBPF programs can see everything that's happening in user space. So whenever a container is trying to run a process or read a file or make a network call, all of that can be seen by eBPF, and that means all of it can be modified by eBPF. And the best part about this is that it doesn't require any changes to the code or configuration, right? Nobody likes adding extra instrumentation code to their application. eBPF does this transparently to the application and to the user because it's running in kernel space. And so let's talk about some of the cloud-native use cases that we have. So the first one is around networking. If you've seen some of the talks earlier from Thomas, he's talking about how eBPF can be used to enhance networking in the cloud-native world, and that's where the Cilium project came in, right? And so what it allows you to do is to either modify or skip the Linux kernel networking stack for increased performance and flexibility. I think some of the cool things around this is, like, for example, Facebook has been using eBPF in production since 2017. So every single cat video that you've uploaded to Facebook has been processed through eBPF for the last 6 years, right? And I've talked to other users that have been using eBPF, and when they switched to it, they found that it reduced their CPU consumption by 72x, right? There's massive performance benefits that you can get by moving to eBPF, and there's also, in terms of flexibility, allows you to create like new networking topologies. So what Thomas was talking about in his keynote about like Cilium Mesh, and also doing lots of fun and interesting things around BGP and SRv6 and other fun telco networking things. The second big area that we're seeing things is around observability. So this goes into, right, the eBPF is seeing everything that's happening on the kernel, so it can observe all of that. And there's a bunch of great projects around that, like Inspector Gadget and Hubble, OpenTelemetry, Packet Where Are You, and Pixie. And it provides you a way to visualize what's happening on your whole system without missing anything. I think one thing that people really like is, since everything's going through the kernel, right? Somebody can't just hide like a malicious application outside of your cluster, right? Say you're observing your Kubernetes cluster, and somebody creates an application on the same host but outside the cluster. If you're only have a tool that's viewing your Kubernetes cluster and your user space thing, you're only seeing what you want to see and not seeing the malicious actor, right? But the kernel sees everything that's happening on the host, so you have complete visibility into what's happening, and it'll be able to find that for you. You're also able to, since you're collecting a lot of data, draw a lot of like information. Though this is, in some ways, I would say like a two-edged sword right now. Everybody knows observability data is good and bad, but sometimes you can be overloaded with it. And I think the key thing here to think about is, once again, collecting the information that's important to you and being able to understand what will be important to you. That hasn't changed, just what you're able to collect and how you're able to do it has changed, right? So the fundamental principles aren't changing, but the tools you have to do it with eBPF are better. And then the last part is around security with projects like Falco, KubeArmor, and Tetragon. This is related to the observability side, right, where you have complete visibility into different things like process execution, privilege escalations, or file access. This allows you to view all of that and take actions on security relevant events. So I think security and observability are quite related, but one is more about when things that you know about go wrong, and the other one's more about things you don't know about going wrong. And so they're both not good, but eBPF provides you an ability to cover both of them. And the last cloud-native use case I'll talk about is around tracing and profiling. And so we're seeing a lot of projects like Pixie and Pyroscope and Parka coming up to profile applications so you can understand what is consuming the resources on your applications. I think one of the cool things, Parka is an eBPF-based application, and the developers behind that did a live stream where they profiled Cilium, and they were able to reduce the CPU consumption of Cilium at baseline, I think by like 10%. And so you're using eBPF to profile an eBPF application and improve its resource consumption. And I think that's quite a cool example of what you can do with tools like this. And with all those different use cases, eBPF really has grown a really buzzing community around it too. So let me walk you through like the eBPF landscape. So there's a bunch of, we like to say major applications because they have lots of contributors and lots of people using it. Tools like BCC for tracing, Cilium for networking, BPF Trace for tracing and debugging, Falco, Catran, which is the Facebook load balancer, Pixie, which we talked about, and Calico, which is also for networking. On top of that, there's so many more projects doing different things that are, this is really, I think, a growing and emerging space. There's a lot of different use cases beyond what I've just kind of scratched the surface with here. And I'm seeing this list grow all the time. And I think if you come back in a year from now, I won't be able to fit this on the screen. It's kind of like the cloud native landscape, if you've ever seen that. Originally, it started off small and a good idea, and I kind of have the same fear with the eBPF landscape, is it's starting off small and a good idea, and eventually it's going to become a mess and something you can't kind of comprehend. So that's on the application side. And on the infrastructure side, we also have a lot of tools like obviously the runtime in the Linux kernel, different compiler backends, and then different projects that are leveraging eBPF in interesting places like eBPF for hardware, an eBPF verifier, and like a conformance testing framework. There's also a bunch of different libraries for helping you write eBPF applications too. The kernel community is growing. This is actually the first patch set from Daniel Borkman, merged in 2014. I think that's one of the funny things that a lot of people don't realize about eBPF is that it's actually almost a decade-old technology right now. But because of that Linux kernel development lifecycle, the point where people started to have kernels where this was actually useful and relevant and they could use it in their applications really didn't start that long ago. And so the applications that could leverage that are just really starting now. So yes, eBPF has been around for almost a decade, but I think we're really just starting to see the explosion of projects and the ecosystem around it. And I'm excited to see that. And in the kernel community upstream, eBPF is actually one of the most active subsystems too. So upstream in the Linux kernel, there is a lot happening every single day too. In terms of eBPF acquisitions, because is this interesting for companies too? We're starting to see this too. Back from 2020, we had Flowmill acquired by Splunk, and the latest one was Pyroscope being acquired by Grafana. I know that there's a lot of eBPF companies being funded and growing right now, and I track all the different companies that are working in this space, and the number of companies that are having eBPF agents or applications is growing, it seems, almost daily. So I think we're going to see a lot more acquisitions in this space too. Beyond just the Linux kernel, eBPF is also being ported to Windows because it is such a powerful technology. I think this is going to be an interesting space because you suddenly have a way to extend the functionality of the kernel, not only on Linux, but also on Windows. And that's going to unlock a lot of exciting opportunities for what you can do on both operating systems. Now, I have talked a lot about the magic of eBPF. I'd also like to put a disclaimer. It's still not a magic bullet. No, technology can be. There's people, processes, and lots of other things that affect how technology actually turns out in the real world, right? And so I think the key thing here is like, yes, eBPF is a tool. In some cases, it's a great tool, but it's not like some of these things, it's not like we didn't have a way to do it before, right? There's different things like dtrace, ftrace, and even IP tables that were working before. eBPF, like when we're thinking about that vision of eBPF inside, we should think about what are the new use cases that we can do. Is this actually something that we're doing because we're hopping on the bandwagon? Or is this something where eBPF is actually a better way of doing it, right? And so just because eBPF is a check mark for some people doesn't mean that the application is actually better. You need to look into some of the details too. So if this has inspired you a little bit, I have a few resources on where to go next. First, eBPF does have a Wikipedia page. This is written by Daniel Borkman, who's the maintainer of eBPF. There's eBPF.io, which is a bunch of great learning resources, including a very long and extensive what is eBPF, if you want to dive more into it after this. There's eBPF Summit, which has been happening for 3 years and has lots of videos. It will also be returning on September 13th, 2023. You're actually the first people in public to know it because we haven't actually announced it yet. You get the little sneak peek right here. So with that, I'd like to leave you with the vision for eBPF inside. Hopefully this talk got you a little bit excited about the possibilities for what eBPF is unlocking in the cloud-native landscape and what's possible with it. And I think another good analogy for what this is, maybe to help conceptualize it better, right, is eBPF. I think is going to become something like, right, the cloud-native app store, right? Before smartphones, we had phones, but they weren't programmable. Suddenly, when we added an application store to our phones, we were able to download new programs and new applications that would allow us to do new things that weren't possible before, right? I can download the SBB like mobile app and figure out how to be routed around Switzerland, right? That was a functionality that wasn't in my phone before, but because I'm here in Switzerland now, I can add that in. And I think that's what eBPF is unlocking for it. And you're gonna want applications with eBPF inside because it allows you to add new functionality into your applications that weren't possible before in a programmable manner. So with that, thank you for coming. Yeah, that's it. And we have a couple minutes for questions.
Any questions? Just talk into the cube. Anybody? Don't hesitate.
It's either really good or really bad, and I can't tell which.
Or I pick someone. Oh, over there. Oh, Jesus Christ.
Yeah. Cool. Thank you for coming. Oh, is there? Oh, okay. Oh, it's Ricardo.
All right. So I have a question on where you see in the vision for eBPF. How much of this do you think will go into core things into Kubernetes? Like one of the challenges that Cilium and other tools in this area try to solve is things like multi-cluster deployments, which have a lot of challenges, but also in the area of scheduling that have to be sorted out elsewhere. How much do you think fits outside, and what could end up being the core Kubernetes stack?
So you're asking if eBPF programs should become part of Kubernetes, is that right?
Yeah, how much of it will actually be for someone that is just doing Kubernetes, as you said, that might not be looking into it, how much of it might end up going there as well?
It's the 101 session, not the 401 session. No, I think that's actually a really good question. But it's hard to say. We actually haven't seen any eBPF like going into like Kubernetes repo itself. I wouldn't say it would be unheard of for it to happen in the future, though. It's a bit interesting because I think most of the applications, like there's the ecosystem around Kubernetes, and those are the applications modifying it. I think we're seeing it a lot in the applications around Kubernetes that are extending the functionality of Kubernetes. Yeah. I don't know. I haven't thought about that before.
Yeah.
Can I kind of
Yeah.
I'll hijack his question? So, I mean, in line with that, I mean, for instance, you know, with the capabilities you just shown, I could imagine that you could rewrite quite a bit of the kubelet so that it's far more tightly coupled to the to the kernel itself, and you get performance benefits of that.
Okay, yeah, actually, yes. So let me go back and answer that. So if you look at Cilium right now, right, it has kube proxy replacement, which replaces kube proxy with eBPF. And I think we're going to see, in a way, like if there's a better way to do it with eBPF, people are going to like start replacing some of that functionality with eBPF because it provides a more programmable, flexible, performant way to do a lot of things. And I think we're going to start to see some of those replacements like we are seeing with kube proxy right now in Cilium. Like, I think going back to the vision statement with like the eBPF inside, like for the majority of people, it's actually not going to make a difference to them right now, right? So the people that are using Cilium in their clusters and are using KPR, like they don't care that it's like kube proxy under the hood or if it's like an eBPF program sorting the traffic. What matters to them is that when they replace kube proxy with eBPF, is they get a more performant, more scalable solution. And so I think in terms of what's going to go, what if eBPF is going to go into like upstream Kubernetes, I think in the places where it can provide more value in terms of scalability, performance, programmability, like I think we're going to see a lot of innovation in there. And I think there's a lot of great use cases that are going to come. But the actual people using Kubernetes, right, shouldn't have to care about that. They're going to care about the solution, not the actual technical details under the hood. And I think that's a great thing. Oh, one question down here. Watch out.
What do you think about stuff like KTLS? Is that taking things too far, or is that like where we want to go? Or
I'd let the community decide. I think
because you showed the slide about one guy saying like a lot of things can actually, or eBPF project can be solved like by bash scripts and stuff, and
yeah,
some people have the feeling that some stuff eBPF or some projects are going like too far, and I don't know. What do you think about that?
I mean, I think that's the fun thing about open source is that it's an experiment. You don't know what's going to work, and right, we're kind of like building on top of lots of different examples. Like eBPF was built off of a lot of the knowledge from like Open vSwitch, right? And so I think it's great to have these experiments because if you don't test out the limits of what too far is, you won't know. But I think if you're actually going to like put something into production, like you should understand like the trade-offs you're making in the different tool choices that you have. In terms of what's too far, like I'm very much an eBPF optimist. I'm paid to be, so I think we're just scratching the surface of like what's possible. Like I think like yes, Cilium has been around for a long time doing the networking, and now there's a lot of companies in the startup space. But like for instance, there's actually a bunch of people here at Google working on like how eBPF relates to security and like LSM. And I think that's a super interesting space that is just getting started. And so I am very positive that there's a lot more use cases for Cilium. Like some of them won't be good, but I think there's a lot more opportunity to be right than to be wrong. Cool. Yeah, with that, we have like 10 seconds left. So I think, yeah, thank you for coming. I hope you learned something.